Okay, and just for the sake of curiosity, I'm wondering what frequency the switching regulators are running at. So I'm going across the input of the transformer. So the switching regulators are running around 47 kilohertz. I'm not exactly sure what that waveform looks like, but imagine it would have to be somewhat sinusoidal to run through a transformer. Now, just for curiosity's sake, I'm wondering if that has a duty cycle, so I'm going to check that. And duty cycle measures the percentage of on time. And yeah, it's 50% on, so that's a typical waveform. Now you may have noticed, but there were actually 3 transformers on the other side of this board, and from what I can see, it looks like they actually just power the sensing and controlling network here. So they measure the voltage outputs like the 12, the 5, the 3.3, the negative 5, and the negative 12, and they feed data back to the switching regulators, indicating that they need to be producing more power. I believe that's what it's for. Not 100% certain of that, but yeah, I just thought that was interesting that those are there just to power the sensing and controlling network. And using a laser pointer, since it's easier than trying to point around with a metal object, this here is an optocoupler, which I believe is used to feed data back to the regulating circuit. It's right here. It's just a 4-leaded device. It looks like an IC. They tend to be white. Alright, and just for curiosity, I want to see what the optocoupler does. So right now there isn't a load, and the frequency of the optocoupler is 198 kilohertz. So I'm going to add a 20 watt or a 20 ohm load to the 5 volt rail, and I'm going to see what happens. Now I don't want to do this for too long since the fan isn't cooling the heat sinks the way it should, but I should have enough time here. And the frequency really didn't change much, so I'm not sure exactly how this feedback network works. Anyway, thought it was worth checking. Now I just want to see if I can find some of these more negative voltages. So going to ground here, sorry about the high frequency. Oh, okay, found the negative 12. Good. Alright, there we go. That sums it up pretty well, I think.